Welcome to FiberStar's Clean Label Plating Module. I'm your host today, Dr. Brock Lundberg, and I'm FiberStar's Division President of R&D and Product Applications. In previous modules, we have already covered basic Citrify chemistry, and for this module, we're going to talk about how the porosity and high surface area of Citrify can be applied to an exciting technology called plating. This is an application area that showcases Citrify's multiple functional benefits with high surface area and emulsification properties. We're going to cover delivering an oil-based ingredient, such as an oil-based flavor or functional fat using Citrify. Because Citrify uses a patented physical process that opens up the fiber, exposing a lot of surface area, the long chains of cellulose, hemicellulose, pectin, and protein give the fiber a unique ability to trap and bind fat while still remaining a dry, flowable powder. As you can see from the scanning electron micrographs shown here, there are many pockets and places for oil to penetrate into the fiber. It is this porosity that gives Citrify the ability to hold 15 to 25% oil on its surface and internal pores. Now let's look how plating can be done on a larger scale. This is a video that we shot at the University of Minnesota using pilot scale equipment with lemon oil and Citrify 100M40. The Citrify was added to a ribbon blender, and while it's agitated, the oil is added using a micronizer or sprayer, and it's sprayed directly onto Citrify's surface. This is a pressurized spray gun, but you can also use a regular spray bar to add the oil. In this example, we're adding 15% oil load, but you can get up to 30% load depending on the type of oil that's used. This is a look at the final product. This can be used in powdered applications or delivered as a flavor to a beverage. Here's a photo of the final product. These are examples of 100M40 with 25% tangerine flavored oils. One of the benefits of this system is that it will take on a bit of the color from the oil. And you can see in the prior example that the lemon oil was also yellowish. FiberStar conducted a study at the University of Minnesota to evaluate the flow conditions of oil as it's plated onto Citrify at various levels. A trapdoor device was used to look at how the product flowed, and at oil loads that were low and the trap door was opened, there was high flowability. At higher levels of oil, the product began to compact slightly and it didn't flow. From this study, we concluded that loads higher than 25% will start to lose flowability as they get above 25%, and this chart summarizes our findings. This slide shows a relative flowability of oil plated on Citrify compared to maltodextrin. On this scale, we scored the powders from 0 to a 10, or 1 to 10, 10 being completely compacted that does not flow, and 1 is completely flowable. With 20 and 25% oil loaded on Citrify, the flowability compares favorably with maltodextrin plated at 4%. However, once maltodextrin was plated with 20% oil, it lost complete flowability. This makes a great case for the cost and use of Citrify as a plating carrier, because Citrify can be used at 5 to 6 times less and still deliver the same amount of oil into a product compared to maltodextrin. Now we'll cover some applications where plating can be used, which includes nearly any application where an oil-soluble ingredient needs to be delivered as a powdered system. Citrify will not only deliver the oil, but it will bring its unique functionality into the system. In meats, for example, a rosemary can be used as a natural antioxidant, plated onto the Citrify and mixed into an injected brine. The brine can then be injected, the rosemary distributed throughout the muscle of the meat or poultry, and the Citrify not only holds the oil and distributes it throughout, the Citrify also can be used for increasing yield, reducing drip loss, and lowering cook loss. This improves the quality and the cost of the final product. Baked goods and dairy are other example systems where Citrify would bring multiple benefits and functionality. Another example is animal feeds, where the delivery of an oil-soluble ingredient like a vitamin could help with the bioavailability and protect the nutrients from being degraded in hard digestive conditions. Here, we're going to show another example of a beverage. This is a lemonade, starting first with the lemon oil that's plated onto Citrify at 25% or 20% oil loading. The mixing procedure is extremely simple, like what we've showed previously, where the Citrify is added into a bowl, the oil is slowly added, and it's mixed until you form a homogeneous powder. The plated Citrify can then be mixed with the sugar, acid, salt, and once it's added to water, it can create a simple instant lemonade. This is a video of the plated lemon oil going into solution. And look how easy the plated oil is dispersed with the sugar in the water, and look how soluble it looks. This is cold water, so the sugar will take a little bit longer to dissolve. But the Citrify not only emulsifies the flavor, it also provides a pulpy mouthfeel, color, and clouding to the lemonade. This is a simple ingredient declaration, which includes sugar, citrus fiber, lemon oil, salt, and citric acid. Here's a look at the clouding ability of Citrify at lower concentrations. Please note that because Citrify is made with both soluble and insoluble fibers, the cloud will settle out over time if there's not a suspension agent in the beverage. Here's another example of a smoothie formulation with unrefined coconut oil that can be plated onto 200 Fg at 25% oil loading, which is compared to a control that does not have any gums or fibers. The plated fat was used in a dry powder smoothie mix, the ingredients blended together and added along with a mixture of ice and orange juice to make an orange smoothie. Because coconut oil has a relatively low crystallization temperature, once it's added to cold juice and ice, it recrystallizes and curdles. There are no protective ingredients in the control, so it destabilizes relatively quickly. After 10 minutes, curdling appears. At 20 minutes, there is phase separation. There is nothing in the drink to protect the protein that was used to create the smoothie. When the coconut oil is plated onto the 200 Fg, the oil is stabilized and curdling does not happen. Additionally, there is protein protection offered by the fiber blend that keeps the beverage stable over time. After 20 minutes, the product's very stable, and after 30 minutes, you can really see the difference between the control and the plated coconut oil. You can see the phase separation taking place with a control, and this is expected because the acid denatures the protein, making it an unstable beverage. Other benefits of using Citri for plating applications include the ease of use. You can easily take an oil and convert it into a dry flowable powder. Citri's clean label. Label recommendations are citrus fiber, citrus flower, or dried citrus pulp. There's no E number, and it can also be a great alternative to maltodextrin and other plating carriers. Additionally, Citri provides benefit including viscosity, stabilization, and mouthfeel into the final application. And Citri helps formulators reduce the number of ingredients used on the label. For example, the lemonade that we just showed in the prior slides. Thank you very much for attending this training module. If you have any questions about the information presented here, please contact us using any of the contact information provided here. And thank you very much for your time.